So we finished up in Iceland. Make sure that the next thing you do is watch Magnetic Storm and filled out the video guide. You can print the guide if you want to, or you can go back and forth. It's up to you. Now we're going to be evaluating the theory of plate tectonics. This is the link you just clicked on that I'm filming right now. And the first thing we want to do is we're going to get out our geological field notebook again. And if you're looking at the hyperdoc, it says complete page 16. What is page 16? Let's see. You go to page 16, and you're going to want to choose a field study location. That would be the Grand Canyon, that would be California, the Himalaya, any one of those places we visit. What observation did you do? What did you do? Describe what you did. What did you discover? What did you find out there? Obviously using complete sentences and filling in the area. How does it relate to tectonic plates is usually kind of the wrap-up notes that I did. And then we're going to go to the back page here. So the next thing says review the evidence on page 17. So we're going to go to page 17 and we're going to review. Let's review. Let's go over this stuff. So the first place we went was the Grand Canyon. Should you be writing this down on your packet? I think so. Grand Canyon. What we learned there was that the Earth's surface changes over time. Geologists use observations of the present day processes as clues to what happened in the past. Remember, it took a lot of energy and a lot of time to form the Grand Canyon. The next place we went was the San Andreas Fault. Which was the Point Reyes fence. And that's in the hyperdoc. We saw two plates, Pacific and North American, sliding past. The force was shearing. It's a transform boundary and a strike slip fault. And we did notice lots of earthquakes, right? Didn't see any volcanoes on those strike slip fault. We just saw a lot of earthquakes. Number 3, Hawaii. Hawaii, we see shield volcanoes, so those gently sloped volcanoes. It's a hot spot, which means it's a leak there in the center of the continental or the oceanic plate. It is magma from the mantle, so it's super deep and hot. It is low silica, so low quartz, low hexagons. Low viscosity. It is effusive. And if you remember, effusive means that non-eruption because it's such hot magma, it's completely melted down. And we're going to have dark rock because we have that low silica, low viscosity, which is going to give us basalt. Next trip, we went to Fuji, Mount Fuji. in Japan. And it is where we see an oceanic plate subducting at a convergent boundary. It has high silica and viscosity. It is explosive because of that high viscosity creates that magma plug like we did with our test tubes. And it's very light in color because of all the silica and quartz. So we see granite. We have, it is a reverse fault. And we see compression being the force acting on it. Compression. 5, Himalaya in Nepal. And here we see converging, and so Mount Fuji, we saw earthquakes and we saw volcanoes. The interesting thing in Nepal is we saw these converging plates and we see earthquakes, but we don't see volcanoes because they are continental plates. It results in mountain building. Results in mountain building. And we found ocean fossils on top. And this is again a reverse fault compression. Next, we have Iceland. And Iceland, we saw 2 plates happen to be oceanic, diverging, which means they are moving away from each other. It's creating new crust. We see the seafloor spreading. And the cooling of this seafloor that's coming up new reflects the Earth's polarity at the time. The older rock is farther away. Older rock, which is farther away from the center of the ridge, have reversals in polarity. So we see the compass pointing south as we go away. And that would be tension as it pulls apart. That's the force, and it is a normal fault. Now, these are the places we visited here. In your presentation, it asks you to talk about each one of these and answer questions. A lot of the answers are right there. The last page, they want you to go other places to prove plate tectonics. And that other place would be kind of a trip around the edges of the continents, or going to see basically that supercontinent of Pangaea. Remember, and this is the evidence you're going to stick in that last slide, we talked about the puzzle-like fit, and you can go on that hyperdoc and go back up, scroll up to the top and see the example of the map that I put up. They had similar mountain belts and rock types. We saw the plant and animal fossils patterned across South America and Africa. We saw the glacial patterns, or you could call them grooves. The terminal moraines, which is basically where the ice age, when it was Pangaea, came down. And you can look at that in the areas. The assignment attached to it is the pages of the book are actually there, but it's the edge of the glaciers. The glaciers pushed everything forward, and then when they melted, they left everything behind. And then we have similar climate conditions. Now, the idea is to eventually turn in this packet. I don't know when that's going to be, but you need it for this presentation, so make sure you go through and make sure everything's complete. That includes, and this will be attached in the document to actually look at, but you want to make sure you filled in these pages, and you really want to make sure that you have 7 earthquakes. So this is page 5. Make sure that you have 7 earthquakes, you have 6 shield volcanoes, and you have 5 stratocomposite volcanoes. Okay. Good luck with your presentation. Let's get to work.